Good afternoon, everyone.
Good afternoon. How are you?
That was good. Some of you are learning to say good afternoon in this country. That's a cool thing to do when somebody says good afternoon. You should say good afternoon back. My name is Mr. Luke. Some of you I've already met in other classes, and I'm a teacher. I travel all across the United States, and I work with students like yourselves and the teachers here at Stafford, and we talk about books. How many of you love math in this book? Yeah, the math people have their hands up, and everybody else says, oh, I hate this stuff. This stuff is dull, dry, boring, hard to read, hard to figure out. Sometimes it's hard to follow their thinking and what's really going on to solve some of these problems. So if I could do it some different and give you some tricks to help you understand this math stuff, would you be willing to try it? All right, so the first thing I did is your teacher told me you're working on 5.3, which is solving quadratic equations by finding square roots. So we're going to do some square root stuff today. I kind of need to see where you are. So that's what this thing is about. This is a little concept check. All right, on the left-hand side, first of all, I'm in Vermont, so I want to check to make sure this is still accurate. Everybody raise your left hand. Your left hand. Okay, left and right's the same in Vermont that is in the other 48. Okay, good. On the left side, right over here, tell me where you are in these things. It says square root, radical sign, radicand, radical, rationalizing the denominator, and inverse operations. On the left-hand side, if you consider yourself an expert means you could teach me, your teachers, or anybody else in this school. I want you to put a plus sign over there. If you've heard of it, know a little bit, but don't consider yourself an expert, I want you to put a check. If something there is new to you and you have no idea what it means, it gets a 0. Let's go ahead and do that now. Rate yourself on all 6 of those. Plus means you're an expert. Check means you know a little bit, or you've at least heard of it. 0 means it's new. And don't feel bad about putting zeros on there. If you don't know it, you don't know it. That'll help me help you. All right, Chinese fire drill. Ever done one?
No.
Here's how they work. You grab a book, hand it to the next person. They hand it to somebody, you hand them another book. And you do that as fast as you can until everybody has a book. Ready, go. Hand it to me. Hand it to him. Hand it to me. Hand it to him. Hand it to me. Hand it to him. Hand it to him. Bam. Would any of the adults like a book? Oh, let's keep going. Teachers want books too. Let's keep them going. Hand it to her. Hand it to him. Hand it to her. Hand it to her. Hand it to her. We got him. We good? Got it. He still needs one. All right. So let's take a look at 5.3 in this book. First thing we're going to do is we're going to preview this because I need to know what I'm getting myself into. Most students, when they look at math books, if you actually look through this thing, it's going to kind of lead the way for you if you pay attention to this stuff. Don't just jump to the odd questions because you know the answers are in the back of the book, because that really won't help you either. So if we look on 5.3, which is page 264, we're going to look at the titles. We're going to look at the introduction. We're going to look at the subtitles. We're going to look at the pictures. We're going to look at the example problems and see if we can figure out what they're doing. All right, so right off the bat, it says, solving quadratic equations is the first subtitle. Square root, bold word. Radical sign, bold word. Radicand, bold word. Radical, bold word. So right off the bat, there's 4 of the 6 vocab words right there. Investigating properties of square roots is a little activity. There's an example, number 1, using properties of square roots. Top of page 265, rationalizing the denominator. You might be thinking, Dude, I put a 0 by that one. Well, that's okay. We're going to get to that. At least we know it's a bold word. It's coming. Then we got example 2. And then we got solving a quadratic equation. So it looks like it's going to start us out a little easy, then it looks like it's going to get a little harder. If we look at 266, modeling a falling object's height with a quadratic function. So there's another problem there to solve. And then we got some guided practice coming up, so we're going to get to practice some of this stuff on 267. All right, so I like these samples. Take a look at example number 2 there on page 265. This is what we're going to practice today. So to practice this, you're going to need a partner. So you two are already there. You can work together as partners. That'll be fine. Let's see. If you do me a huge favor, jump back there. You can work with him and be his partner. I'm going to let you 3 guys just be a triad. Okay. All right? And so you'll just take turns. Yeah, everybody remembers the joke, don't you? So here's what this is going to look like. This is what it sounds like when you paired read. So if I was going to pair read something to you, everything I do mathematically, I'm going to show you what I'm doing, and I'm going to tell you what I'm doing, and so I'm going to say it. So I'm going to take that first example. It actually says 2x squared plus 1 is equal to 17. All right. This is what you're going to sound like when you talk to your partner.
You need a better marker?
Let's see.
Black is better.
Ooh, this is new.
And this is new too. The black is new.
All right, awesome. 2x squared plus 1 is equal to 17. All right, the first thing I got to do is I got to kind of look at that and see, well, what am I trying to do here? I guess I'm trying to solve this thing. I'm trying to simplify it. So the first step, if I was going to solve this, is exactly what it's going to sound like when you talk to each other. The first step is I want to start working my way toward isolating this variable by itself. Right now I've got 2x squared plus 1 is equal to 17. I know if I use inverse operations, I can get rid of that 1. So if I subtract 1 from both sides, and I have to do it from both sides to keep it equal. Now when I combine my like terms again, I'll end up with 2x squared is equal to 16. Now, I still need to get that x squared, or that variable, by itself. So I want to try to get rid of that 2. If I use inverse operations and I divide both sides by 2, I'm going to get x squared is equal to 8. So we're starting to whittle it down. Now the next step is, okay, I still need the x. I want x squared. I want to know what x is. All right, so if I take this thing and say, okay, x is going to be equal to the square root of 8. Now, is that as low as that can go? No, because now I'm sitting here thinking, well, if I know my times tables really, really well, this is the same thing as the square root of 4 times the square root of 2. Now I could do that one. Does that make sense? So as you're working through these problems, I want you to talk to your partner. So here's how it works. You're both going to have a piece of paper. One of you is going to do all the work and all the teaching. If you're not sure, just slide the paper over to your partner and he'll take over. If I see you playing ping pong, I'll know you need my help. That makes sense? All right, and so here's what I want you to think about. On your paper somewhere, on a piece of paper, in English, write down the steps that I did to do that. Right over here. If I was going to create a process and say in English, this is what happened there. So in other words, this is what was given to me. This step, I want to get rid of the 1. And how did I get rid of the 1? I used inverse operations. I subtracted 1 from both sides. Now, you, in your own words, tell me what you think happened next. Right from those steps for me. Right. What do you think happened next? May you go to the restroom? I need 2 forms of ID and your mother's maiden name. You got all that stuff? Do you got a hall pass?
I can draft one up.
What does she do to get you to the restroom? Whatever it takes. Yeah. I was kidding about the 2 forms of ID. Your partner left you. So when in a minute, I'm going to have you talk to your partner. I just want you to talk to yourself. Have you ever talked to yourself before? Do you answer yourself too?
Not usually.
Don't, because there'd be something wrong with you. Don't ever do it. Don't ever. You can talk to yourself all day. Don't answer yourself. Then people think you're weird. All right, here's what I want you to do. I want you to talk to your partner about what you wrote down. See if you can agree, put your heads together, see if you can agree on what that procedure should be, because it'll look different when you read each other's minds. See if you can agree on what that procedure should be. Go ahead and talk it over. So what did you put? This guy's got, he's got stuff written down too here, so
We're
I'll see.
working with the second one of the whole set.
Yep, the same one. So what, so
Divide both sides by 2.
why'd we do that?
So we can get rid of the 2 and then just have the variable isolated.
Okay. Yeah, we're constantly working toward getting that isolated
Yeah.
to solve this thing. Okay. All right, so you guys got anything in common that you wrote that even remotely looks the same, or did you all think about it differently? Did you all say it differently? You still working through it?
Yeah, well, I
You
was.
No.
Okay.
All right. First one's given.
Guys, have anything that even remotely sounds the same?
One from both sides.
So what did you do?
I wrote down.
Get rid of it. All right.
Divide by
So why are we getting rid of the 1?
Divide by the 2.
We don't need it.
We don't. Well, we don't need it. I like that. We're trying to simplify it. I like where you're going with that. But why did I pick the 1 first? Why wouldn't I divide both sides by 2?
Because that's the easiest place to start.
Hmm?
That's the easiest place. Oh, because that's not its total value. If you divided that by 2, you still need to incorporate the 1 in there. Or is it order of operation?
Order of operations is a possibility.
Would it be the opposite of PEM does? Because you're doing it forward, you do it backwards to unsolve it?
Like unraveling it, you could go backwards to check it. Okay, I see where you're going with that. That makes sense.
Okay, so the square root of both sides from the square root of 8 upon square root of 4. Because the square root of 4 is 2 multiplied equals 4, and 2 is equal to 8.
All right, so got a couple of things. I like the way you're thinking about this stuff. I asked somebody, why did you get rid of the 1 first? Well, because it makes sense to do that. Help me understand why it makes sense to do that. Why?
Because you want to go with the opposite of what the equation says, you have to do it in reverse. So whatever the last thing is done on the equation, do the opposite.
So there's never So to get rid of that 1, to get the isolate the variable, get this by itself, it just makes sense to subtract the 1 first? Do you just see it that way, or why are you seeing it that way? If I know 17 minus 1 is 16, does that change the way you think? What do you think? Because I know if I get rid of that 1 first.
It makes the equation easier because.
Help me understand easier. Why do you say easier?
If you divide 17 by 2, it's gonna come up with like a decimal or.
I'm going to get a decimal number or a mixed number if I try to do it as a fraction. So by getting it down to a 16, you saw that you factored that in. See how much stuff you're leaving out in your thinking? You do things on autopilot sometimes and you think, oh yeah, that's what I should do first. Make sense? And sometimes that's okay to think that way. The hardest part about math sometimes is figuring out your way through the journey. So let's think about this one. All I want you to do is think about it. What would you do first? Write it down. 3 times the quantity 2a minus 5 is equal to 15. Write it down. What would you do first? What do you call that when, I know what you're thinking, what do you call that when you take that times that and that times that? What's that property called? Starts with the letter of alphabet. Starts with the letter D of the alphabet. That's a property. Second letter is an I. Distributive property. Ever heard of that one before? Okay, good. Just checking. So what do you guys think you do first?
Distributing.
You're distributing?
Multiply everything.
You just told me if I could see through it, it looked easy, why I would do this first. Right? Isn't that what you said a minute ago?
Yeah.
You said, I look at the problem and it looked easy. So you would distribute that first.
Mm-hmm.
Why?
Because you can't subtract 5 from 2a.
Is that okay?
You divided by 3. Both sides by
I divide both sides by 3 first. Did I break a rule? But you told me earlier, based on my thinking, it looked like the easiest way. So you could distribute that 3. There's nothing wrong with that. But if you look at, once you get good at this math stuff and you kind of look at it, I know 3 times 5 is 15. If I divide both sides by 3, the 3's gone.
True.
Does it work? Well, let's see. 2a minus 5 plus 5 is equal to 5 plus 5. 2a is equal to 10. A is equal to 5. 6a minus 15 is equal to 15. 6a minus 15 plus 15 is equal to 15 plus 15. 6a is equal to 30. A is equal to 5. There's always more than one way to skin a cat, but I liked it whenever you said, figure out the way that makes the most sense, that seems to make it simple.
Mm-hmm.
Now, when you look at a problem, how do you figure that out really? She's really good at that because she's been doing this math for a while. I don't know if you figured that out. It's not her first day in math. But when you guys start to think this stuff through, you got to think in your mind, logically, how would I do this? The same thing's going to happen whenever you start looking at the radical sign, you start looking at square roots. You learned about factor trees a long time ago, right? So if I look at this problem, solve it, write it down. Tell me what you would do. Tell me what you would do. And I'm curious what that, because I want to apply this easy philosophy. I'm trying to figure out what it is. Because you keep telling me do what's easy. I need to know what that means to you. Tell me how to solve this. How do you find the square root of 72? How do you think you'd do it? Write it down. Okay, so you're using the factor tree. I like that. Okay, I like that. That's a thinking process. I like that one too. That's a different thinking process. What two numbers could you multiply together to get 72? What's 8 times 9? Say 72. Just start there.
Not really fresh in my mind.
Ooh, that's different. I like that. So far I've got four different ideas in this room. All right, here's what I want you to talk it over with your group. Talk it over with your group. See if you can share your ideas. See if you come up with one you think will work. I've got 4 different ways to do this sitting in this room right now, which is interesting. So what new numbers would you multiply together to get 72? 8 times 9, right?
Oh, yeah.
Start there.
Oh, okay. I didn't know. Okay. All right.
So it'd be square root of 8 times the square root of 9.
That was a
What are you thinking?
I'm not sure if I did it right though.
I certainly, you have the thinking down. You don't have the numbers in the right order. I'll tell you that much.
Okay.
But I like what you did, but I just don't like it completely.
Okay.
What did that? Put down the equals. Put a number.
Okay, I got 2 big ideas floating around the room. I got this one, and I got this one. Help me with which one's easier for you. Because I still don't have my head around this idea. When you said do what's easy, I don't know what that means to you. Help me. What does easy mean? What does this break down to? Write it down. Does that break down further? How could I break down square root of 8 and the square root of 9? Do I need to? What should I do? What should it look like? All right, I like where you're going with that. Ooh, I like that a lot. I got a paper in the room that looks like this. Now what? Does that make sense? Does that make sense? Now I'm asked the same question. Which one's easier? Because I still don't know what that means to you.
36 and 2. Because there's less of a process.
There's less what?
Less of a process.
There's less of a process? Why is there less of a process?
Because with the 8 and 9, you had to do the square root of 8. Which
So it almost like, it's sort of like a factor tree kind of a
Yeah.
deal, if you remember factor trees.
there's less in the 36 and 2 than there is the 8 and 9.
But what made, because you're the only dude who wrote down 36 times 2. Why'd you do that?
Because half of 72 is 36.
So your process in your mind, you took the number and tried to divide it by 2 right away.
Yeah. Make it smaller. Easier to work with.
But yet everybody else took 8 times 9 because you remembered your 9's times table is 9 times 8 is 72. That seemed easy. Is divided by 2 the right reason why you did that? Or did you just get lucky in the fact that 6 times 6 is
Just got
36?
lucky.
You're like the blind squirrel that finds an acorn once in a while. You found an acorn. Okay, that's fair. But I need to know what you're thinking, because when I solved that problem and I saw that, I was thinking 6 times 6 is 36, and I know that that's a square. And so that made it easy for me. I never thought about divided by 2 first.
Well, because that's what we did with the 8. We divided it by 2, and then, because that was 4, and that's pretty much how we did that.
So that logic you think will keep work? So what? Well, let's see. Write down what you would do. Write down. Don't talk to your neighbor yet. Write it down by yourself. Write down what you would do. All right, so here's what we missed. We got through this and we started looking at this one. And we said this was the same thing as this times this, which makes your answer 6 square root of 2.
Okay.
Right now, tell me what you think you'd do to do that one. Don't talk to your neighbor yet. I don't know what your neighbor thinks. I want to know what you think.
Or your calculator.
You can use. I don't have a problem with the calculator as long as you know garbage in, garbage out. You just got to realize if you put garbage in a calculator, you get garbage out of a calculator. Tell me what you think you would do. This is where, remember, whenever your teacher constantly talks to you about your times tables and how important they are, it makes life a lot easier. So what do you think? Where's yours? Ooh, I like that. I like that. I got a paper in the room that says that. Huh? And it's not yours. Is it yours?
Well, I did that because this one was way
You're trying to divide them by 2.
Yeah.
See, you told me earlier it's easy to divide by 2. 125, that's 62 and a
Only
half.
for even numbers.
That's what what's on the board.
So is it divided by 2, or why'd you pick 25 times 5? You guys both did the same, something similar. Why'd you pick 25 times 5? Lucky, right? Blind squirrel found an acorn. What are you thinking?
Well, if the number ends at 5, it's probably divisible by 5.
Okay, I like that one. I like that thinking. So that could be, instead of your thinking divided by 2, divided by 5.
That ends in a 5 or a 0.
So, all right, that makes sense. But in this case, when you look at that 5, if you know 25 times 5 is 125, what do you know about 25? I can take the square root of it real easy because I know 5 times 5 is 25. So to solve these problems and to think this stuff through, it's going to require you to do a lot of analysis of the problem, going in and saying, okay, what's the easy way? I like what you said. I'm just trying to make sense of what you think easy means. Because if you're going to work your way through these problems and solve them, you got to find the easy way. The easy way is if you really truly know your times tables, you try to figure out what the squares are that are in there. That makes sense?
Yep.
All right, so we got some practice problems here. And all I want to practice right now is getting through these squares. Take a look on 267. Now, you're not going to rush through these all by yourself. We're going to use that paired reading idea. So one person's going to do the first one. That's going to be me. Then you'll do the second one and you'll teach him and he watches. Then you'll do the third one. You teach him and he watches. Then I do the fourth one. I'm taking a turn. If you work ahead, you would be doing way more work than you need to. So don't do that. Just stay with me. All right? So that first problem. Square root of 18. Here's what it will sound like when you talk to each other. I've got the square root of 18. If I use my main man's easy method, I'm going to say that's the same thing as 9 times 2. I'm going to say 3 square root of 2, and I'm done. It's like tying up the calf at the rodeo. It's 8 seconds. That makes sense? Now, you go first, and you go first. Number 20, square root of 48. Only one person does all the work in the group. What does it mean for that to be easy? So if you're talking, tell them what you're doing. You just listen and watch. Everything you're doing, you talk and you tell them. You guys just watch. If you get stuck, you can slide the paper. And if not, I'll be around the hall. All right, he's going to do everything. The first one, all you got to do is watch. So what would you do?
Square root of 48. What we do.
If you want to walk around, this will show you so much insight in how well they know the multiplication table.
Oh, I know.
It's right off the bat, they did 6 times 8. No, 16 times 3, and you're done. But they don't know the easy way because their math is not sharp.
Right.
So just walk around, just look at their
Right.
paper.
I haven't started this. We've been just graphing.
Right.
Averages, so.
I like where you're going with that. You got 24 and 2, you broke it down. Now you got to break it down some more. Keep going.
Yeah. So we're gonna do 4 and 12, right?
You slid the paper? Okay, that's fair.
Paper.
He's not doing anything. He's just watching. He's doing the work. So you got 24, 2. That's awesome. Now, can 24 break down some more for us? You know your multiplications tables, right? What times what's 24? 12 times 2, 4 times 6, 8 times 3. Do any of those sound like they'd make a really cool square? I wonder if that's maybe the wrong road to go down then. You got any other ways you can get to 48 besides 24 times 2?
Divided by 10.
That's going to get you 4.8. That won't work.
Divided by 4? Could you? 3?
So here's the deal. If you guys get on your multiplication tables better, it's going to help you out a ton. So what's 16 times 3? Say 48. Does 16 seem like a good square?
Yeah.
What times what would get you 16? 4 square root of 3 and you're done. Makes sense? That makes sense? So you got to look. I love the fact that he said the easy way. So what you got to do, think logically, mathematically. Start thinking about numbers times numbers, or squaring numbers, or taking the square root of numbers. It's just the reverse of the other. Now it's going to be. Yep.
So while he was doing it, I was thinking because he already.
You were
did it.
thinking?
Yeah, I was thinking, and I could just do 16 and 3. So that was way.
All right. So my man here says, while these guys were teaching me, I'm thinking about this. He says, I'm going to take 16 times 3. Why? Why'd you pick 16? Say, because 4 times 4 is 16.
4 times 4.
And it's a square.
Yeah.
I love the easy way. What we're going to learn to do in this class is we're going to learn to actually find the easy way. Now, whoever went that turn, it's the next person's turn. And we are doing 21 is the square root of 27. Square root of 7. Find me the easy way. Find me the easy way. Teach each other. What's the easy way to pull that off?
I already got it. 9 times
What is it?
3. 3 minus 3 equals the square root of 3.
Write it down. Tell them how you did it.
Damn, that's you, buddy.
So why'd you pick 3? Why'd you pick 9 times 3?
Well, because 9's a square.
9's a square. I love that thinking. That makes so much sense. Did you guys get there? Look at you, man. Nice job. I'll take.
No, he's got to do the 4. Wait, you're doing 22, right?
Yeah, I don't want to, but I will. That's a hard one. Okay, it's my turn. I'm sitting here looking at the square root of 52. Now I'm starting to think about what you said about being easy. Well,